Okay, so today we'll be working on 2.1 notes, quadratic equations. So let's recall that a quadratic equation is ax squared plus bx plus c, and that has to equal 0. So our quadratic formula is x is equal to the opposite of b, add or subtract, square root, b squared minus 4ac, and we divide all of that by 2 times a. Okay, our solutions that we get here, those can be called our roots. They can be called zeros, solutions, and then also if we have a real solution, that's going to be equal to our x-intercepts. Okay, then we have our discriminant. So remember that our discriminant, we find that by b squared minus 4ac. So it's just what's underneath the square root in our quadratic formula. Okay, but now if our solution, if our discriminant is greater than 0, then that means that we have 2 real answers. If our discriminant is less than 0, then we have 2 imaginary solutions. And then if our discriminant is equal to 0, then we have 1 real solution. Okay, let's take a look at our first example. And please keep in mind that you can pause the video at any time. If I am going too fast, pause it and then unpause and you can check your work. So we want to find the real roots using the quadratic formula and completing the square. Okay, so we have x squared plus 4x equals negative 1. So if we're going to use the quadratic formula, the first thing I need to do is get that to equal 0. So I'm going to have x squared plus 4x. I'm going to move my 1 over, so plus 1 equals 0. So now I have my a, my b, and my c. So we have x equals the opposite of b, add and subtract. We're going to have b squared minus 4 times a times c divided by 2 times a. Okay, so I'm going to end up having x is equal to negative 4, add or subtract square root of 12 all over 2. So I have x is equal to negative 4, add or subtract 2 root 3 all over 2. And then to simplify that one step further, we have x is equal to negative 2, add and subtract the square root of 3. Okay, so next we're going to find the real roots by completing the square. So I have x squared plus 4x. Okay, 4 is my b. So remember, you always want to divide b in half and then square it. So 4 divided by 2 gives me 2. And then if I square that, I get plus 4. Okay, now whatever I add onto the left-hand side of the equation, I have to add to the right-hand side. So negative 1 plus 4 will give me 3. Okay, then I'm just going to take x plus 2 squared is equal to 3. Okay, if I square root both sides, get x plus 2 is equal to plus or minus the square root of 3. So then I have x is equal to plus or minus the square root of 3 minus 2, which is the same thing if I rewrite this to be negative 2 plus or minus the square root of 3. Okay, next we are going to be using our graphing calculators to prove the answer in part A. I will have to switch between my tablet and my calculator, so I'm sorry if the video gets a little choppy. So first we have x squared plus 4x plus 1 is equal to 0. So we can kind of sketch this graph. So remember, to find the vertex, we take the opposite of b over 2a. So that would be negative 4 divided by 2 times 1, which gives us negative 2. Okay, so my vertex is going to be negative 2 comma some number. So then I just substitute my x being negative 2 back into the equation. So negative 2 squared plus 4 times negative 2 plus 1, and that's going to give us negative 3. So my vertex is going to be negative 2, negative 3. So if we come over to the graph, okay, so negative 2, negative 3 would be down here. And then I'm not really positive what the graph's going to look like yet, so we can figure that out once we use our calculator. All right, so you should have your graphing calculator out. We want to go to y equals, we're going to type in our equation. So we have x squared plus 4x plus 1. Okay, then I can go ahead and hit graph. All right, now I want to find my roots or my zeros. So I'm going to go to second calc, go down to option 2 to find our zeros. Okay, then I'm going to go all the way over to find this first one. You want to make sure that you are a little bit left bound. Then I'm going to go down, I'm right bound. Then we're going to hit enter again, so it's going to guess. So I have negative 3.73 comma 0 as my first zero. So you could go ahead and write that down on your paper. Okay, then we're going to do it again. So I'm going to go second calc. Let's go to 2. Let's go to this side. So am I left bound? Yes. Am I right bound? Yes. And it will guess again. So we have negative 0.27 comma 0. Okay. Okay, so if we transition back to here, our x-intercepts that we found were negative 3.73 comma 0, and the second one was negative 0.268 comma 0. Okay, now if you're using, go ahead and check with your calculator. Our first one, that is equivalent to negative 2 minus the square root of 3 comma 0. And our second one is equivalent to negative 2 plus the square root of 3 comma 0. So that's how we can check and prove that our answers in part A are accurate. Okay, and then if we'd go ahead and just finish the sketch of our graph, we have negative 3.73, so that would be somewhere over here, and negative 0.26, so right about over here. And go ahead and sketch your graph. So it'll look something like that. All right, so now we want to determine how many real roots the following equation has. So this is where we're going to be using the discriminant. So recall the discriminant, that is b squared minus 4ac. Okay, so my b is the square root of 3, so square root of 3 squared minus 4 times a times c. Okay, so that's going to give me 3 minus 3, and that is equal to 0. So if you scroll back up or look at the top of your paper, if the discriminant is equal to 0, that means that we have one real solution. So that would be our answer, one real solution. Okay, next we are going to use the quadratic formula to determine the sum and product of the roots for this equation. So let's first use the quadratic formula. We have x equals opposite of b, add and subtract, b squared minus 4 times a times c divided by 2a. So if we do some simplifying here, I get negative 2 plus or minus the square root of 8 divided by 2, which then equals x is equal to negative 2 plus or minus 2 root 2 all over 2. Simplify that one more time. We have x is equal to negative 1 plus or minus the square root of 2. Okay, so the first thing we needed to do was find our roots. So we did that by using the quadratic formula. So now I know that root 1 is equal to negative 1 plus the square root of 2, and root 2, or second root, is root 1 minus the square root of 2. Okay, so it's asking us to find the sum and the product of the roots. So the sum, just going to add them up. So I have negative 1 plus the square root of 2 plus negative 1 minus the square root of 2. My square root of 2's cancel, so I end up with negative 2 as my sum. Okay, then we want the product. So I'm going to have negative 1 plus the square root of 2 times negative 1 minus the square root of 2. Okay. If we double distribute, I'm going to end up with 1 plus the square root of 2 minus the square root of 2 minus 2. Simplify that. We have 1 minus 2, which equals -1. Okay, so the sum was -2 and the product was -1. So the product and sum of the roots. So the product R1 times R2 is always going to be equal to C. Okay, and root 1 plus root 2 is always going to be equal to the opposite of B. But it is very important to note that A must be 1. So note A must be 1. If it's not 1, you're going to have to do some division to get it to equal 1. So we want to find the sum and the product of the following. So we have 4y squared minus 28y plus 9 equals 0. So if you recall, A must be 1. In order to get that to be 1, we have to divide everything by 4. So I end up with y squared minus 7y plus 9/4 equals 0. Okay, so we want to find the sum and the product. So if you recall, the sum, root 1 plus root 2, is equal to the opposite of b. Well, the opposite of b would just be 7. And then root 1 times root 2, so the product, that is equal to c, and c is 9/4. So we were able to find the sum and the product. Okay, and for our last example, we're going to find a quadratic equation when we are given the roots. So we want to write our answer in ax squared plus bx plus c equals 0, with a, b, and c being integers where a is greater than 0. So we're going to work backwards a little bit here. I'm going to rewrite my roots and I'm going to distribute the 1/2. So root 1 is going to be 1 plus the square root of 5/2, and root 2 is going to be 1 minus the square root of 5/2. Okay, so we need to find a, b, and c. So we know that the sum of the roots is going to equal the opposite of b. So the opposite of b is going to equal root 1 plus root 2. So the opposite of b is going to equal 1 plus square root of 5/2 plus 1 minus square root of 5/2. So the opposite of b is going to equal 2. So b equals -2. Okay, then we know that c is going to be equal to the product, so root 1 times root 2. So I have 1 plus the square root of 5/2 times 1 minus the square root of 5/2. So c is going to equal 1 minus 5/4. So c equals -1/4. Okay? So we know that a has to equal 1. So I am going to go ahead over here. So I'm going to have x squared minus 2x minus 1/4 is equal to 0. Okay, but it's telling us that a, b, and c are integers where a is greater than 0. -1/4 is not an integer, so I'm going to have to multiply everything by 4. So now I'm going to have 4x squared minus 8x minus 1 is equal to 0. And that would be my quadratic equation.